In the last section of Chapter 8, we're going to talk about spheres. Now, a sphere, what is it? A sphere is the locus of points in space that are a fixed distance from a given point called the center of a sphere. A radius of a sphere connects the center of the sphere to any point on the sphere. A hemisphere is half a sphere, and something called a great circle. If you ever hear of a great circle, that's the circle that divides the sphere into two hemispheres. So here's a hemisphere. The great circle is the circle that cuts it into that. So let's start with this problem right here. This is a little confusing to understand. This figure shows a hemisphere and a cylinder with a cone that has been removed from its interior. Now the cross sections have the same area at every level. So the volumes are equal by Cavalier's principle. So let's look at this. This cross section of a circle is the same area as this cross section of a circle with another circle removed. And as you go up, the little top here, that's going to be the little part left by the ring at the top of the cylinder. So they're actually the same. So the volume of a hemisphere is equal to a cylinder, the volume of a cylinder, subtracted by the volume of a cone. So if you actually did this, the volume of a cylinder is pi r squared h. Subtract the volume of a cone, 1/3 pi r squared h. You actually get 2/3 pi r cubed. And that is the volume of a hemisphere. So if a hemisphere is 2/3 pi r cubed, the volume of a sphere will be twice that, so it's going to be 4/3 pi r cubed. So at the bottom here, you will see, right there, the formula for volume of a sphere. 4/3 pi r cubed. Example number 1, which you should be writing in your notes, says find the volume of a sphere in terms of pi. Step 1, we write down the formula. 4/3 pi r cubed. We know the volume. It's going to be 9 cubed. And we simplify that into 972 pi centimeters cubed. Example B. Find the diameter of a sphere with volume 972 pi inches cubed. Well, we're going to write down the formula. 972 pi equals 4/3 pi r cubed. Now, if I multiply both sides by 3/4 and then divide it by pi, you would get 729 r cubed. Well, the cubed root of 729 is 9. So that means the radius is 9, therefore our diameter would be 18 inches. Pretty easy. C, the volume of the hemisphere. Well, if 4/3 pi r cubed is the volume of a sphere, the hemisphere will be 2/3 pi r cubed. And the radius is 4. We plug that in, and you would get 128 pi divided by 3 meters cubed, your answer in terms of pi. So in example 2, we're going to talk about a giant squid. Now a giant squid actually has really large eyes. They need to see their prey in low light. The eyeball of a giant squid is approximately a sphere with a diameter of 25 centimeters, which is bigger than a soccer ball. A human eyeball is approximately a sphere with a diameter of 2.5 centimeters. How many times as great is the volume of the giant squid eyeball as the volume of the human eyeball? So if we find the volume of each, and you could actually fast forward this video if you want, find the volume of each. Actually, I'm just going to skip ahead. So I find the radius of each, plug it in, and here are my answers. The human is approximately 8 2/10 centimeters cubed, and the volume of the squid The eyeball is about 8,181 centimeters cubed. So divide them approximately how many times greater? A giant squid is about, the eyeball is about 1,000 times greater. So now we have another concept. In this figure, the vertex of the pyramid, which is shown, is at the center of the sphere. The height of the pyramid is approximately the radius of the sphere. Suppose the entire sphere is filled with n pyramids that each have a base area, B, capital B, and height, R. So here's the volume of a sphere. Approximately 1/3 base area R plus 1/3 base area R plus, and then it keeps going. The volume sphere, the sphere of the volume, is close to the sum of the volumes of the pyramid. So 4/3 pi r cubed, substitution, I plug that in. Now n is the number of times this occurs. So the number of times this occurs times the formula for a pyramid. I multiply both sides by 3, and that means this. And I get 4 pi r squared, and I divided both sides by pi. E is approximately the number of sides, or the number of pyramids, times the base area. If the pyramids fill the sphere, the total area of the bases is approximately equal to the surface area of the sphere. So 4 pi r squared is approximately S. As the number of pyramids increases, the approximation gets closer to the actual surface area. We have just proven the formula for the surface area of a sphere, which is this, 4 pi r squared. Example 3, A. Find the surface area of a sphere with diameter 10 in terms of pi. So we write down the formula. Surface area equals 4 pi r squared. We plug in the radius. Surface area equals 4 pi times 5 squared. Well, 5 squared is 25 times 4. And what would that give you? It would give you 100 pi, and then our label, feet squared. So 100 pi squared feet. B, the volume of a sphere with surface area, 144 pi squared meters. So let's plug in 144 pi equals 4 pi r squared. I divide both sides by 4 pi. And that gives us what? 36. So the radius is 6. I now plug that into the formula for a volume, 4/3 pi, and then 6 cubed. 6 times 6 times 6 times 4/3. That would give us 288 pi cubic meters. And C, the surface area of a sphere with a great circle that has an area of 4 pi squared inches. Well, the area of a circle is just what? Pi r squared. So I just divide both sides by pi. R squared means 4, so the radius of that circle is 2. So that means the radius of the sphere is 2. So the surface area would be 16 pi squared inches. In example 4, I've given you all of the work. It asks, if the radius of a sphere is tripled, what effect would that have on the volume? Now, you should be able to do this with no work. That's why I'm giving it to you. Now, you can take the radius here of 3, and it's actually labeled meters. 3 meters, plug it in. And then triple it and plug in 9 and see what happens. But once again, if we are tripling the radius, think of our formula. 4/3 pi r cubed. Well, volume, we're cubing it. So we're going to be multiplying it by to the third power. Or taking 3 to the third power. So if we're tripling it, 3 to the third power is being multiplied by 27. So if the radius is tripled, the volume would be multiplied by 27. And lastly, you can pause the video, actually do this one yourself. Find the surface area and volume of the composite figure. So surface area and volume. So you can pause the video and skip ahead if you want. So let's start with the surface area. Well, surface area of a sphere is what? It's 4 pi r squared. So we know the surface area of a hemisphere would be 2 pi r squared. So the radius of the hemisphere, 2 pi and then 49, since the radius is 7. So the surface area would be 98 pi centimeters squared. So that's the hemisphere. Now to find the area of the cone, we don't need the part that's butted up to the hemisphere, because that's a circle and that's not part of the surface area. So all we want of the cone is the lateral area. So the lateral area of a cone is going to just be pi r L. Well, pi, the radius is 7. L is what? It's 25. And so that's going to give us 175 pi centimeters squared. We add them up. And the surface area would be 273 pi centimeters squared. Now for the volume. For the hemisphere, the volume is going to be 2/3 pi r cubed. So we can just plug in 7 cubed. So the volume is going to be 686 pi divided by 3 centimeters cubed. Of our cone, it's going to be 1/3 pi r squared multiplied by height. So 1/3 pi 49 times the height. Well, wait a minute. What do I have to do for my height? I'd have to use Pythagorean theorem. That would give me 24 as the height. So the volume of the cone would be 392 pi centimeters cubed. If I added both of those together, you would get a final volume of 1,862 pi divided by 3 centimeters cubed.